Hello, let's continue our Sudoku adventure with Sea Breeze by Jean. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have these thick blue lines in the grid. These are region sum lines. What you do is you look at wherever they cross box borders, and that segments the line. So this is a segment of length 4, and this is a segment of length 2. And they're always going to be within the same box, because crossing a box border makes a new segment. And so you can't repeat any digits within a segment just because Sudoku doesn't allow you to. But the rule set doesn't specify that, but that's kind of consequence. But what we need to do here is each segment has the same sum as each other. So however many segments they all have the same sum. So if this was, say, I don't know, 5, 6 adding to 11, then that means these 4 cells also add to 11. And then, so that's our region sum lines. Then the very thin teal lines are our modular lines. What you do is you take any set of 3 adjacent digits on the line, like these 3, these 3, these 3, the overlapping set of 3, and you're going to have one of each of 3 different groups, each group being a different remainder after dividing by 3. That's why they're called modular lines. It's modular math. So one of them would be from 1 or 4. One of them could be from 2, 5. One could be from 3, 6. It doesn't matter the order, just these 3. Notice we have 1 from each group. But then these 3, we also need 1 from each group. These 3, we need 1 from each group, etc. For both of these lines, you can repeat digits on the line as long as other rules allow it, meaning the lines aren't adding an additional non-repeat rule. They're just using Sudoku non-repeat and whatever other additional constraints they have. There's no implied non-repeat. And then for the black dots, this black dot here, these 2 digits have a 1 to 2 ratio, meaning 1 is double the other. So if this was 2, this could be 1 because 2 is double 1, or it could be 4 because 4 is double 2. All right, and that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself, and I'm going to get started right now. Okay, well, this is quite limited because 4 digits add to at least 10. 1, 2, 3, 4 adds to 10. These 2 digits add to at most 11. So this is going to be either a 5, 6 or a 4, 6 to add to 10, meaning it always has a 6 on it. And then these digits are going to, if it was 10, it would have to be 1, 2, 3, 4. Think about 11, though. 11 is going to add 1 to this sum, meaning one of these individual digits is 1 higher. But since they're all in the same box, we can't repeat any digits. So we can't do 2, 2, 3, 4. We can't do 1, 3, 3, 4. We can't do 1, 2, 4, 4. So we're going to have to do 1, 2, 3, 5 for 11. Meaning we always have 1, 2, 3, which I'm not actually going to keep corner marked, but we always have 1, 2, 3, and then we're with a 4 or a 5, leaving behind the other 4 or 5 along with the 6. So there's always a 6 here. That 6 points down, saying this can't be 6, placing the 6 here. And we have a 4, 5, 6 triple there, leaving 1, 2, 3 here. All right. This is going to be the same. So this is going to be 4, 5, 6. The 6 ends up here. And then, because we must have a 6. Because 6 cannot go on here. And then this is going to be the 6 with a 4, 5, leaving a 1, 2, 3 this way. Okay. And then, yeah, that's basically what we know. These are 1, 2, 3 with the other 4, 5. I think, yeah, we can place the 6 here. 6 is one of those 2. And 6 is one of these 2. Okay. So I think that's going to basically, Sudoku will take care of the region sum lines at this point. As long as we remember 6 has to be one of those 2. So we don't need to worry about the region sum lines anymore. I put a 4, 5 on this black dot here. I just wanted to get through the region sum logic first. But you can't actually put a 5 on a black dot because you can't have it to 2.5 and you can't double it to 10. So this has to be a 4. That's a 5. 4, we're going to have half that to 2 because we can't double it to 8. So these are not 2s. 4, 5. So this is going to be 1, 2, 3, 4. That's fine. These are 1, 3, 5, I suppose. Does that help me? Okay, I think I have to do the modular lines now. Okay, so we know where the 6s go. So I guess there's something to talk about with modular lines. It's just important to know about them in general. It's just basically they're cyclical because if we think about these 3, we have 1 of each. We have 1 from 3, 6, which is here. And so these 2 are from 1, 4 and 2, 5. We don't know which is which. But we could color them. We could say green, purple, orange. This is the green group, the purple group, the orange group. We know the green group is 3, 6. We don't know if purple is 1, 4 or 2, 5, but we know orange is the other one because these 3 have to have 1 of each. but also these three need one of each. And notice we already have the purple and orange group. So this has to be the green group. And luckily it is a 6, so it is. And now these three need one, right? So it's going to cycle. This is going to end up purple, and then this is going to end up orange. So we know that neither purple or orange can have the 3, leaving the 1 and 2 here. That places the 3 here. That is green. Okay, and there's a 1 down here somewhere. I think I'm only going to color on the lines themselves, but now that we know this is green, we actually know this has to be green as well, making it a 3 or 6. Because of the 1-3 pair, it can't be 3, so this has to be the 6. That places the 6 there. All right. Also, these couldn't both be green, and because one of them was 6, the other one was not 3 or 6. This also can't be 3 because it's not a green group, so that's 1, that's 3. Now, 1 was orange. Oh, we know 1 is orange, so 1 has to go with 4. That's cool. That's 5. And so this now is purple. Oops, this is purple, which is a 2-5. Only 2 is left. And so now this is orange, and this is purple. So notice that these go in different orders. This is green, purple, orange, green, purple, orange. This is green, orange, purple, green, orange, purple. So they don't have to be the same order. This is 2-5. This is 1-4. Neat. I'm only going to color the ones on the modular line, so I don't feel like coloring the whole puzzle today. That's 3, that's 1, that's 5. I feel like Sudoku is just going to finish us real quick. So that's a 3, that's a 4. We really just have Sudoku left. So let's just do these pairs here. I need a 1-2 pair here, and I need a 3-4 pair here. That's 3, that's 4. Over here we have 1 or 2. Here we have 1, 2, and 5. The 5 goes here. And this is 1 or 2. What does this box need? The box needs a 1, which goes up here. It needs a 2, which goes down here. It needs a 3, which goes exactly here, placing the 2 and the 1 and the 2 and the 1 and the 2, placing the 1 and our 4, and we're done. All right, cool. Nice puzzle, Gene. I liked the interaction there. This black dot luckily resolved our some digits early on. As soon as we saw this could only be 4, 5, it actually could only be 4. So that was neat how the 6s interacted, how the modular lines interacted. And they ended up being different types of cycles, which was also cool. Nice demonstration there. All right. Well, I enjoyed this. Let me know how you did. And if you enjoyed it, why not leave a like, subscribe, and a kind comment below.